We're going to be looking at the graphs of polynomial functions. Some of this is going to be review, and then some of it is going to be new, which is good. We're building off of information that we already know. So first question you might have, in case, you know, some jargon here. A polynomial is in the form of y equals some term x to the power of n plus ... all the way until you get to a coefficient. So the biggest thing with a polynomial is a polynomial needs to have a variable to the power of some exponent, whether that's a 1 or 6, or it could be something of that nature. You can't have a square root. You can't have anything other than that. So it's pretty straightforward with this. There are some characteristics based off of polynomials. So let's say, for example, that I have y equals 4x to the third minus 5x plus 6. Okay, so what this is going to tell us is our characteristics of this polynomial. This is what we considered standard form. Standard form is where your exponents go in order. So it's going in descending order. I have my x cubed first, and then my x, and then no x. Okay, so leading coefficients all the way through, or exponents going down all the way through. Since this is my largest exponent, the 4 is considered a leading term coefficient. And that's because that 3 is our highest exponent, which represents the degree. So the degree of this polynomial would be 3, and that's because that is the highest exponent in this polynomial. And since that's the highest exponent, again, the leading term coefficient is that 4. Okay. When we are looking at the graphs of polynomials, we have two different situations. We have an odd degree versus an even degree. Within that, there are two different characteristics. If we are looking just at the odd degree column, an odd degree column, if that leading term is positive, what that means is that our polynomial is going to look something in the form of this. Okay, it could be a little bit different. It could have more humps in that term. It could be a little bit more straightforward. If our leading term is positive, the end behavior is going to be, your arrows there are going in opposite directions. Okay, if your leading term is negative, they're still going in opposite directions for your end behavior, but notice which direction it's going. The leading term is positive is going to be going in the upward direction, where if the leading term is negative, it's going to be in a downward direction. Okay. Now, let's look at our even degree. If we have our leading term is positive, we are going to have something in the form where both arrows are going in the same direction because it's an even, but because our leading term is positive, it's going in the up direction, which makes sense. So if we're talking about an even degree, and the leading term is negative, you guessed it, it's going to be going in the downward direction. Okay, and that makes sense because you were talking about, okay, are we going to negative or are we going to positive with that leading term? It just gives us an idea of where the graph is going. The next thing is talking about different characteristics based off of these graphs. Okay, so let's say I have a graph or a polynomial that looks like this function right here. There's several different things that we notice in this, and this is kind of review a little bit. This is what we call a maximum. We have a min. We have another max here, technically, because we have different points. And then we have, the book calls them turning points. I personally, to me, these are roots or zeros. It's just deciding where is the graph. Ooh, sorry, not turning points. Roots or zeros, turning points, according to the book, is where is the function is changing from increasing to decreasing. It's kind of talking about your max and mins, so I'm not too worried about it. I'd rather you call them mins and maxes because that's changing direction of whether it's increasing or decreasing. I don't like the term turning points, but we'll go with it. Anyway, so we have our max and mins based off of this, our roots and our zeros, which we can see graphically, and these are things that we've talked about before. The big thing here, though, is determining the difference between your maximums. Since you have two of them, you have to determine which one is actually bigger. So for instance, this left hump looks like it's taller than that other hump. So this one is going to be the absolute max, and this one is going to be called the relative. Because the relative, it's not truly the maximum for the whole polynomial, but in that area, it's the top of that graph. It gives us where the top of that hump is. So you should be able to kind of look at these different characteristics, figure out, okay, where's my mins and maxes? Where's stuff turning? Where is it changing from increasing to decreasing? Where are my roots and zeros? If it's an odd function, which way are the arrows going? So looking at this one, my arrows are both going down, so I know it's an even function, and the leading term coefficient would have to be a negative because they're going in the negative direction. So we're just looking at those different characteristics of graphs.